Hey class, in this video I'm going to be covering adding sound assets into a project. So for the purposes of the video, I'm going to be working with the 3D particle system that we made last week. I'm going to add a couple changes there just to simplify it, and then I'll also demonstrate adding some physics stuff to the particles. It'll kind of be review from some stuff you probably did in MMP 210 in 2D, but this time it'll be in 3D. This is basically just review. You should have done some of this in MMP 210, but I wanted to review it here so that you have the option of adding sound to your final project if you're interested in doing that. So this week, just be one video. It'll be relatively short and pretty simple assignment. Just look for some sound effects and plug them into the particle system that you already created. That way you can start to think about your final project. And next week we'll work on the final project pitch. I'll make another video kind of going over the expectations for that. So you can look for that. But if you want to start thinking about the final project, you can look at the requirements here. And if you have any questions, we can talk about it either in Discord or in one of our Blackboard meetings. So I'm just going to get into adding some sound to the particle system. I'll first add just a general background sound, and then I will add some shorter sounds for sound effects. So I'm going to get started with that. So I'll make a new project. So I'm going to go to GitHub and go to my MMP 310 repo, and I'll open up my project in Sublime. And then I'm going to make a new folder. So I'm going to click Show in Finder as well and go to MMP 310. And I have this 3D particle system. I'm going to duplicate this folder and work from here. So I'm going to duplicate and call this 3D sound. And so I'll just add in some files here to play sounds. There's a few things that we need to do to make that work. And then we will work on the project. So if you want to add sound to a project, the first thing you need to do is add the sound library. So sound support is not a default thing in P5. So if I go to the P5 website and go to libraries, if we scroll down, you'll see one of the first libraries is the sound library. We can open that up and we can use this to play sounds. But we need to actually download the library and put it in our project. It's a little bit hard to find, but you can see the download link right here, and I'll include that in the YouTube video as well. So when we click here, this will take you to the GitHub for that sound file. If you click raw, and I'll try to remember to link to this file, that's the actual code. You can just download this and save it in your folder. So if I hit Command S on the Mac, I can go directly to the folder. So I can go to MMP 310, go to sound, and then just save p5.sound.js. So if I look at that sound folder now, I can see right there p5.sound.js. Depending on what browser you're using, when you save this file, it might end up in your downloads folder, so it might not give you the option. So if it does go into your downloads folder, all you have to do is go and find it. So just open a new window. On Windows, you would just go into the file browser and go to downloads and then find that p5.sound.js. Once you have the library, we just need to add it to our file in index.html. So let's open that up. So basically the library is another script tag like this one. And it kind of looks like P5, but instead of min, we have sound. And it has to go after p5.min, but before anything else that we want to use sound in. So let's just put it right after the p5 library, p5.sound.js. And so now we'll be able to use sound. I'm going to change the title here to with sound. So I'm just going to make a couple changes to this project and then add some sound into it as well. So I'm going to go to Sublime Server and get that started. And so I'll just open this up in the browser. I'll go to localhost 8080 and go to MMP 310. Oh, and I forgot to add a link. So let's go back. I'm going to go to index.html at the bottom here for the main page and just add in a new link under the last one. So this is 3D sound, and I'm going to say 3D particles with sound. All right, so that's everything we need to create that link. And so let's go look at our particle system. So there's the particle system that we created last time. I'm gonna make some changes here. One thing is that since there are a lot of particles here, I'm just gonna change it so that we add the particles by interacting, so that we're not just like constantly making sounds. And then we'll add some physics to the particles as well. Okay, so let's start just by playing a background sound. There's a lot of different ways that you can get sounds. I would recommend looking for Creative Commons or open license sounds so that you don't have to worry about using sounds that are created by some other so you don't have to worry about using sounds that are owned by a musician or artist. One resource is the Free Music Archive. I'll link to this in the YouTube video. You can click search FMA, and then you can download different sounds based on either different radio stations or communities. You can go to different genres. You can look at a lot of different stuff. So let's take a look and see if we can find a sound that we like for background music. Let's see. All right, this is the top rated track. It's not so bad. So we could just go with this. But you could search around here for different types of music to find something that you like. And when you're ready, you just click the download link. That might, depending on your browser, again, it might take you to a to the downloads folder, or it may open up a file here. You can just click the download from that menu there, and then that will go into your downloads folder. So I'm just going to grab this file and throw it into our project folder. And so now we can load it, and loading a sound in P5 is very similar to loading an image. It's just an external asset, so we use the preload function. So I'm going to open up sketch.js. A lot of this stuff I'm going to leave the same, but we're going to add some sounds in here. So I'm going to update the note here to say adding sound to 3D particle system, and this is the 16th. And so I need another global variable for my sound, so I'm going to say variable music, and then because I'm going to be using it in the setup function as well as the preload function, I need to make sure to make it a global variable so it's accessible everywhere in my code. So then I'll create the preload function. And I just need one preload function to preload any images or sounds. I can do them all in the same function. So then I'll just say music equals load sound. And that's one of the functions that the P5 library, the P5 sound library will create. So we're going to load sound, and then this track has kind of a long name, so I'm going to try to get the whole thing. You could also just copy it from the Finder. It's kind of a weird, I guess they must add in underscores for anybody who has spaces in the file names. Okay, I think I got all of that right. So you might want to play your music as soon as the page loads, but you actually can't do that with the more recent version of Chrome and JavaScript. You actually need a user input in order to trigger a sound, at least to start the audio. So instead of just playing it immediately, we'll just make a keyboard press function that will start the sound. So I'll say function key pressed. And you may remember this from MMP 210. This is like mouse pressed. It's just a function that listens for when the user hits a key, and then we can decide what to do. So inside here, we can use if statements to determine what key was pressed. So I'm going to say if key code equals 32. which I remember is equivalent to the space bar. And the way that you can figure that out is to go to this website, keycode.info. Okay, and any key you press, it'll show you what the key code is. So if I hit 32, you'll see, or if I hit space, we'll see it's 32. You might want to include some instructions for the user as well to start the song. So once we hit that key code, we can say music.play. And so if I hit play, we should hear that. And you can see that if I hit the key again, what happens is that it plays another version of the song on top of the original version, which is not exactly what we want. So we can also add in a check to make sure that the music is actually not playing or playing, and then decide what to do. So we can use another if statement inside our key code statement. So we'll say if music dot is playing. So this will just tell us if the music is playing. So if it's already playing, we can just pause it. And if it's not, then we can play it. So that way we won't be in, we'll be able to pause the music if we want to, which will be useful because we, might want to turn it off for a second while we're working. And then the user will also be able to play and pause the music and won't have to, accidentally be playing the song over itself. So let's try that. I'm going to hit space once. And so that starts the song. And if I hit space again, it stops. But then it starts in the same place because I used pause. If I did stop here, it'll stop the song and the song will go back to the beginning. So I'm going to leave that as pause. And then we'll come back here because we can also use this to add more particles into our system in a little bit. So yeah, that's basically all that goes into playing a sound. For our particles, I'm going to add some more sounds, and I'm going to show you guys a couple cool techniques to kind of randomize the sounds. I'm going to make a few changes to the particle system first. So I'm going to add some physics to it so we can give like a reaction, or when we see one of the particles bounce, then we can play a sound. So I have to make a couple changes to the particle system to do that. So the first thing I'm going to do is I'm just going to take out this particle system.add from draw. That way we won't be constantly adding particles. It starts to get pretty annoying if you're playing a lot of sounds every time you add a particle. So let's just move that. So I'm going to take it out of there, and I'm going to put it inside our key pressed. Since we're already using the orbit control to move around the scene with the mouse, I don't want to add more stuff to the mouse. So I'm just going to I'm going to add another key code here. I'm going to say if key code equals, we can do 13 for enter. You can really choose whatever key you want, but those are some basic defaults. That's where we'll add a particle. So I'll just say particle system.add, and so that'll add a particle every time we hit enter. So we'll start with 0 particles, and then each time I hit enter, we get a new particle. So we can control a little bit more our particle system. The next thing I'm going to do is add a little bit of an environment so that we can start to make our particles like actually interact with the environment. So we're going to visualize that environment first. And you guys can feel free to use the same kind of system that I'm using here. But if you want to make changes, you're welcome to. So I'm just going to draw like a little box so we can see the particles. And then we'll just have the particles bounce off the box. It'll be pretty simple. So I'm just going to say I need to have basically a size so I know how big the sort of world is. So I'm going to create another variable and say box size. And I'll start with something maybe kind of small so we can test. So I'll start with like 250. And that'll just be the size of our box. We can make that bigger later. And I'm just using a box because it's very simple. It's going to be really easy to do some collision detection on the box. So we won't have to worry too much about doing fancy collision detection stuff. So I'm just going to draw the box, and I'm going to make it see-through. So I'm going to do kind of like almost like a debug style. So I'm going to set the stroke to light green. and then I'm going to do no fill, and then I will do a box. Pretty straightforward, and it's just going to be box size, and I'm just going to do one input here, so it's going to apply to each side of the box. And so we should see a box now. Yep, so there's the front view of the box, and then we can rotate using our orbit control. And if I add a particle, we're gonna have to turn off that stroke. But we can see those particles right now are kind of bouncing outside of the box. And so what we wanna do is kind of contain those particles. So we can add some little physics detections into our particles to make them bounce around in the box. So normally in MMP 210, this is something that we did in 2D. And so now I just want to show in 3D. It gets a little more complicated, but it's still very simple to do just some collisions. So let me make sure. I'm actually just going to do push and pop for this stroke and fill, so I don't have to fix it anywhere else. I think that should do it. Yeah, I can add some particles. So now we just need to detect if our particles are going outside the box. All right. So for that, we'll go over to our Particle.js. And we have this update function here that's doing a bunch of stuff like updating this position, the speed, color, rotation. And so we're going to use that function just to detect if our particle has left our box. So I'll do that down here. I'll do box collisions. And really, since we're doing this in 3D, essentially when we add a particle, sorry, I keep hitting the sound button. When you add a particle, it's going to be right in the middle of the box there. And basically, we know the center of the box is 0, 0, 0. And we know the width of the box is whatever box size is, as well as the height, as well as the depth, the z value, which we can see here. So if we see a particle go and it reaches a point above the y value of the box, then we can know that that's a problem, and we can say stop here and go back. So we'll detect that first. We'll use the y first just because you can see our particles are moving up. So we're going to say if this dot position dot y, it's pretty simple. We just say if it's greater than box size divided by 2. Okay, if that's true, we just need to reverse the y. So that's a little bit trickier because we have both speed and acceleration. So if we change the speed, that's useful, but the acceleration will continue to go in whatever direction it's going. So we are going to have to reverse both of those. So you might remember this from MMP 210, but to reverse a number, we just multiply it by -1. That gives us the opposite of that number. So I can say this dot speed dot y multiplied equals -1. We get the opposite of the speed, and this dot acceleration dot y, same thing. So even though we're working with 3 axes and speed and acceleration, we're basically doing pretty much the same calculations that we would do in 2D. So let's try that. Oh, and you know what? I said greater than, but I kind of forgot that y goes positive this direction. So this is actually negative. This is negative box size over 2. So let's just flip this guy around and see if that works. Oops. So negative box size over 2. So we'll add actually that rule I had before is correct, but we have to look at the negative first since we're going up. So if y is less than negative. So remember that y goes negative as it goes up. So if it goes negative greater than, if the negative value is less than the negative box size over 2, then we know we've traveled that far. So now if I add in, okay, so now we're bouncing off the top of the box. Now if we can do the other directions, we can prevent the x and z from leaving over here. So we basically just have to copy this and paste it for X and Z. It's going to be exactly the same because the box has equal dimensions in all three axes. So we'll just change all of these guys to X and just change all of these guys to Z. Doesn't actually matter what order you do it in, but we usually go X, Y, Z. So I'm just doing X, Y, Z. And so now we should see our particles. So they're bouncing off some of the walls, but not all of the walls, because we haven't detected every wall. We've only detected basically the top of the box, and then this side of the box, and then this side of the box. These guys, all three of these, we still haven't done yet. I'm going to increase the lifespan of these guys just a little bit so we can view that a bit longer. So we can see we're getting some bounces, but not all of the bounces. So how do we get these last few walls? Well, we just reverse everything. So if we're going negative this way, then we're going positive this way. So we just flip these guys. So I'm just going to add. So here we can add a compound conditional, where we're going to say or. Okay, so the two lines for or, if this dot position dot y is greater than positive box size over 2. So that's if it goes to the other side. And so we can just add that in to all three of these guys. And feel free just to copy and paste this part because it should work the same for everybody. So now we should get particles going in every direction. Yep. We still have this like general velocity upwards, so we could randomize that just to get some more variation, although it is kind of funny to see the particles kind of floating around. So if we wanted to get a little bit of difference in the velocity or the acceleration, we could just add some randomness here. So I could say like random, maybe negative 0.5 to 0.5. And I'll leave the Y the way it is just because it's nice to get that little floaty effect. But we'll just put some random numbers in for the X and Y. So this is for the acceleration. So that's the speed over time, how much it changes. So we're going to see a much faster. Oh, that's probably too fast. So let's do 0.1 here. We'll see faster acceleration dynamics though. Okay, so that's pretty fun. So let's just try adding in some sound effects now. Since I'm using cats, I'm gonna find some cat sound effects. Another good resource for Creative Commons sound is freesound.org. This is mostly hobbyists creating and uploading sounds. It's completely free. The only thing is that you have to have a login, so you have to create an account in order to log in to download sounds. So since I'm working with cats, I'm gonna look for a meow sound. It's a pretty good one. It's a good one. So there's a bunch of them right at the top here. So I'm just gonna go ahead and download these. Depending on what you're working on, you might want to download different types of sounds. These cat meow sounds are probably going to get pretty annoying pretty quickly. So I may choose something else. But I'm just going to try it. It might be kind of funny. So once I download those sounds, I'm just clicking the download link. They'll give you a little bit of information about the sounds. So the file size and the type of sound and things like that. We don't really need to worry too much about that for P5. It should be able to play most types of sounds, especially if they're typical sound files like a WAV or an MP3. So I have my 3 meows here. And what I'm going to do is I'm going to randomize which sound plays. So that can add a lot of nice effects. You can make some sort of, you can add a bunch of different sounds without having to assign them specifically. So I'm just going to name these meow 1, meow 2, and meow 3. When you download sounds from freesound.org, they usually have these really long names, so I usually just rename them. And I'm just going to throw them in my sound folder. And so I have to preload those sounds as well. So I'm going to make a list for these. We covered arrays a few weeks ago, and it's going to actually make things a lot simpler if we just do an array instead of doing 3 different variables for each sound. So I'm going to say variable meows and just make a list here. And I'll say list of meow sounds. And so normally what I would do is I would say something like this, meow whatever equals load sound. And then I would load the sound file. So I would say meow1.wave. Okay, so I need to do that with 3 files into the same list, so I can just use push. So instead of using assign here, I'll just say meows.push, and then I'll just put the load sound directly into that part of the list, and that's all I have to do. It'll add it to my list. So then I'll just copy and paste that a couple times, and then change these file names. And so after that, if I reload my page and I look at my meows list in the inspector, you can see now I have 3 sound files in my meows. And so for each one of those sound files, if I wanted to play it, I would have to say meows at 0.play. So that works fine. But if I want to not have to worry about which one is going to play, this is another way that I can use the random function besides generating random numbers. I can choose a random file from a list. So I can say random meows.play. So when I say random and give it meows, it's just going to choose one of these 3 sounds and then play it. So that's pretty simple. I'm just going to put that right directly into my particle constructor. So as soon as the particle is created, it's going to play one of these meows. So that's kind of fun. It obviously will get annoying pretty quickly, but let's see what it sounds like if I put it into our collisions as well. So I'll just put it right after I change the acceleration and the speed. I'll also just play a sound. So we'll hear a sound when our particle hits the wall. Okay, so that's obviously going to get pretty annoying. So one last source for making sounds that's really useful is JFXR. This is a JavaScript-based video game sound creator. And it's really nice because we can try some basic sounds like a pickup, a laser explosion, but we can also just do random and it'll generate some random different sounds. And then it's really easy to save them. You can just click export and it'll download the sound for you. So let's use maybe the hit. So we can do some different hits. I kind of like this first hit that I got. And you can also use the mutate function to take one sound and then make slight changes to it. So let's export one of those. And export that one. So now we've got a few sound effects that we can throw in instead of having a bunch of meows. So I have 4 of these. I'm going to do the same thing. I'm just going to do hit 1, hit 2, hit 3, and hit 4. And I'll include a link to the JFXR in the video. So I'm going to do the exact same thing here. Instead of playing meows, I'm going to play hits whenever I hit a wall. So I'm going to change this to hits. And then go back here. And so after meows, I have hits. Okay, this is my list of hit sound effects. And I'm just going to do the exact same thing. I'll say hits.push, and I'll push in a new sound. So I'll load hit one dot wave, and then I'll just do that 3 more times, and I'll just update these numbers to get the different files. And I think that should pretty much do it. So now we'll get a meow when we first see the particle, and then we'll get hits when we hit the wall. So that's pretty fun. Now we can add in our background music as well. So one last thing that we can do with the sound that's kind of fun, and I'll just throw this in as a last little bit of example, just another thing that we can do with the sound library. So I'm going to go back to the sound library. So there's a lot of different stuff we can do with sound. We can change the sound rate, we can change the pan, the stereo panning, we can synthesize sound. I'm just going to show one example because it is a little different than how we would normally work with P5. So I'm going to look at the P5 amplitude. We kind of already looked at the sound file. We're going to look at the amplitude now. There's a bunch of other stuff you can do, but I just want to go over this because it's a little different than how we would normally work. We've seen stuff like this before, the new keyword with our classes, but we've never seen anything like this, P5.amplitude. So that's a class that's inside of the P5 library. And so if we want to use the amplitude of the sound file, we have to create this P5, this amplitude. So I'm just going to add this, and I'm just going to apply it to the box size. I guess I'll move let's change that to a var just to be consistent. I'm going to move these guys up here just so we can have all our variables together. And then I'm going to create an amp to measure the amplitude. And so then inside setup, I'm going to initialize the amp. I'll say amp equals new p5.amplitude. So that's a little different than how we normally work with stuff. Since the sound library is an external library, it uses slightly different syntax based on what the developer created for this library. And so then with the amplitude, we can measure all the sounds in the environment, but since we're making a lot of extra sounds besides the music, I just want to connect the amplitude to the actual music that we're using. So after I create it, I'll just say amp.input, or wait, set input. So just from the documentation, and I'm just going to use the music as the input here. And so that'll just give me a number between 0 and 1 that represents the volume of the music. And so I can actually use that to set anything in my scene. So I'm going to try the box size. If that's too chaotic, maybe I'll try like a light color or something like that. So I'm just going to say, before we get to the box, so I'm going to get the amplitude of the music. I'm just going to say var level is amp.getLevel. So that just gives me whatever the value of the music amplitude, which is like the loudness. So let's log that, and you should see that it corresponds to the music that we're hearing. So you can see the numbers changing, and if I'm not playing music, then we're not getting anything. So we just get 0 if we're not playing anything. Okay, so let's plug that into the box size. So I'm going to map that value. I'm going to say box size gets map. We're going to map the level. The range of the level of the music is 0 to 1. So 0 is completely silent. 1 is as loud as the music gets. And we'll map that from our original box size, 250, to something bigger. So I'll just do 300 and see if that's not too chaotic. Okay, so there's our box, and there's our box with the amplitude map to it. Since we're using the box size as a global value for our edge detection, even though the box size changes, our cats still know where it is. All right, so let's see if we make it even more dramatic, like 500. So we can see there's a lot of extra collisions happening because the cats are getting stuck as the box moves. We might want to do some kind of smoothing or something like that, so it's not just jumping up and down. But for a demo, this is not too bad. All right, so that's basically how we're going to add sound into our 3D environment. So it's a little bit silly, but I just wanted to do something kind of fun. And you guys, can just add some sounds and play around with stuff and add in your own 3D composition as well. And then, if you want to use some of the stuff like the sound on the final project, but not in the 3D, the things will still work on their own. I'm just adding sound into the 3D since that's what we've been doing for the last few weeks. So as usual, I'm going to add this onto GitHub. So I'm going to say adds 3D sound example. And then I'm going to push to the origin. And so I'll include links to the site and the code in the YouTube video, as well as links to the resources that we looked at. If you do have any questions, as usual, just let me know on email or Discord. And that's it for this video.